Two squirrels, Bushy and Jumpy, have collected 2021 walnuts for the winter. Jumpy numbers the walnuts from 1 through 2021 and digs 2021 little holes in a circular pattern in the ground around their favorite tree. The next morning, Jumpy notices that Bushy had placed one walnut into each hole, but had paid no attention to the numbering. Unhappy, Jumpy decides to reorder the walnuts by performing a sequence of 2021 moves. In the kth move, Jumpy swaps the positions of the two walnuts adjacent to walnut K. Prove that there exists a value of K such that, on the kth move, Jumpy swaps some walnuts A and B such that A less than K less than B. This is problem 5 from the International Mathematical Olympiad 2021. It's an interesting problem, both challenging and enjoyable to solve. The trickiest part of this problem is to fully understand and then translate the problem into a mathematical solution. With only 28% of participants solving this problem perfectly, it clearly stands out as a challenging test of problem-solving skills. Let's solve this problem step by step. First, we will start translating the problem into mathematical terms. Then we will prove by induction. There are 2021 walnuts. Jumpy has numbered walnuts from 1 through 2021 and digs 2021 holes. Bushy then randomly places one walnut into each hole. Next day, Jumpy goes to a specific walnut and performs the following action. At move 1, he goes to walnut 1, then he takes two adjacent walnuts and swaps their positions. On the second move, he goes to the walnut 2 and repeats the same step. He continues this process with walnut 3 and then walnut 4, and so on. The number of moves, K, is the same as the walnut number he is reaching. We have to prove that at some point when Jumpy swaps two walnuts, the walnut number he reaches is between the two numbers on the adjacent walnuts being swapped. First, we start with a small sample of 7 walnuts. In this diagram, each walnut is a circle. On the first move, Jumpy goes to circle 1. The adjacent circles are 4 and 5. He swaps them. So on move 1, K is less than the numbers on the adjacent circles. On the second move, Jumpy goes to circle 2. In this problem, we're interested in comparing the number in adjacent circles with K. Except the circle he visited, other circles are greater than 2. We will mark blue for circles which he visited. At the same time, blue circles also have smaller numbers than K. Now Jumpy then swaps 4 and 6. Notice that the color of circles doesn't change due to swapping. Next, Jumpy moves to circle 3. Now circle 2 is blue since it is less than K. Jumpy switches two adjacent circles, which are greater than K. Since both are greater than K, there is no change in color. On the fourth move, there are 3 blue circles. When Jumpy reaches circle 4, we observe that one of the adjacent circles is smaller than 4, and the other is larger than 4. We have to prove when there are 2021 walnuts, there is such a condition at one point. Now we can simplify the problem as follows. Imagine we have a set of circles, each representing a walnut. We start selecting a circle and check the adjacent circles for the solution. Then we change the color and then select another circle. We continue this process, selecting one circle after another. We have to select all the circles and change colors. At the same time, we have to look for a condition where a selected circle is between two circles of different colors. In this example, at move 6, we see that the adjacent circles have different colors. However, we need to prove that in every combination of 2021 circles, there will always be a circle that lies between circles of different colors. To prove this, we'll use mathematical induction. When we start with 7 circles, we select a circle and change color. To consider the worst possible scenario, we continue by selecting this alternate circle and change to blue. Then move to this alternate circle and change color as well. Now, except for these 2 circles, the other circles are colored alternately. Eventually, when we reach one of these red circles, it is between different colored circles. Now, the question is whether we can arrange to avoid this condition by coloring every circle alternately. No, because for any odd number of circles, it's impossible to color all circles alternately. To make an alternate color, we need the same number of blue and red circles. This means we can make alternate colors with 8 circles. When there are 9 circles, it's not possible to have an alternate pattern. Therefore, we can conclude that for every odd number of circles, there will always be a circle that lies between different color circles. When we notice 2021 as an odd number, we can finally conclude that Jumpy will always reach a walnut where the number is between one smaller and one larger numbered walnuts.